Good morning. I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Minister of Aeronautical Engineering, Dundigal, Hyderabad. In the present video, I would like to discuss the problems on surface integrals. In the previous video, we have seen how to form the surface integral and the surface integral definition and double integral f bar dot n cap into ds, where ds is based on the projection on xy plane or yz plane or zx plane. The value of ds will be dx into dy by magnitude of n cap dot k bar, like that. And we have seen several things and we have solved one example also in the previous session. Now I would like to see more examples on the surface integrals, how to evaluate the surface integral based on the given function and given surface area. Now the first problem is evaluate integral f bar dot n bar into ds, where f bar is a vector point function 4xz I bar minus y square j bar plus yz k bar, and s is the surface of the cube bounded by x is equal to 0, x is equal to a, y is equal to 0, y is equal to a, z is equal to 0 and z is equal to a. So here the region is given as cube bounded by, suppose if it is, assume x, y, z axis, and this is xz plane, this is xz plane. The equation of xz plane is, y is equal to 0. So y0 means it is xz plane. Similarly, it is xy plane. What is xy plane equation? Xy plane equation is z is equal to 0. Similarly, this is yz plane. This is yz plane. The equation of yz plane is x is equal to 0. So these are the three boundaries. And the other boundaries of the cube given as x is equal to a. X is equal to a. I will show by diagram. This is, suppose if you extend the diagram by using like this. So this is a cube and the yz plane equation, x is equal to 0. The left side plane is x is equal to 0 and xy plane means this is z is equal to 0 and back side xz means it is y is equal to 0. And the plane which is parallel to x is equal to yz plane, this is x is equal to a plane. That means what? This is the point a comma 0 comma 0 and this is 0 comma a comma 0 and this point is 0 comma 0 comma a, because all are having lengths a and it is a cube, all are having same equal length. So this is x is equal to a plane and the back side, this is the plane y is equal to 0 and this plane is y is equal to a and z is equal to 0 is the bottom plane and upper plane z is equal to a. So these are the boundaries already given there. And we have to find the surface integral, that is integral f bar dot n bar into ds, where f bar is given this one and surface area is given this. So clearly here this cube has clearly 6 sides. This is one side and this is the other side, parallel side. This is third one, the parallel one is fourth one, and what is other? Back side. This is fifth one and front side sixth. So there are 6 faces of the cube. We have to integral for each and every side. That is integral f bar dot n bar ds is nothing but integral over the face. Suppose you can name it as O, A, B and C. OA, BC. This is one plane. Next OA, D, OA, BC, DE, FG. So here, suppose if you want to consider the surface integral over the surface OABC or OABC, CB. This is OACB is one plane. And what is the other plane? The parallel plane is EDGF or EFGD. EFGD, that is another plane, plus along with OBFE, OBFE, plus along this is the plane ACGD, plus, and the last one, last before, this is EDAO, OADE, the backside plane, plus the front side CBFG. So we have to evaluate the surface integral across the surfaces OACB, EFGD, OBFE, SCGD, OADE and CBFG. So in adding all these, we will get the required surface integral of the given function f bar is equal to this vector with respect to the surface of the cube, right? So what is given here f bar? What is f bar? Here is given is 4xz I bar minus y square into z bar plus yz into k bar. So the given f bar function, this is the surface. So you have to evaluate accordingly along with all the surfaces, that is first surface, second, third, fourth. This is x is equal to 0 is 1, x is equal to a is other, y0, ya. And like similarly, z is equal to 0 and z is equal to a. There are 6 surfaces. You have to find the line surface integral along to the all surfaces. Now I am considering, first I will consider OA some EDGF. This is EDGF. You can do in any order. I'll take, so suppose I consider, I will draw here also the diagram. So based on this, I can show that. So the cube is like this. So it is all having equal lengths. So this is the cube. This is the O, A and B, C. And what is other? So I will give the number D, E, F, G. D, E, F, G. So now I consider case 1. What is the case 1? So here for the surface EFGD, for the surface EFGD. What is EFGD surface? This is z axis, x, y, and this is z is equal to a plane. This is clearly z is equal to a plane. This is xy plane is z is equal to 0. This is z is equal to 0 and z is equal to a plane is at a distance a from the bottom. Z is equal to 0 plane this is, and after a distance this is 0, 0, a. This will be the z is equal to a plane. Z is equal to a. So now I want to find out the surface integral across the surface EFGD. Here the outward normal vector. What is the outward normal vector? N cap or n bar is equal to outward normal vector is along the direction of z axis. So n cap is equal to k bar. The outward normal vector n cap is equal to k bar. Clear? This is the surface and the outward normal vector to the surface is along with z axis. So n cap is equal to k bar. Therefore, f bar dot n cap is equal to, what is f bar dot n cap? So it is, f bar is what is, this is n cap is equal to k bar. F bar is 4xz I bar minus y square j bar plus yz k bar, the dot product with k bar. So what you will get? I bar dot k bar 0, j bar dot k bar 0, only k bar dot k bar 1. So this value is equal to, yz. This value is equal to yz. F bar dot n cap is equal to yz. Now integral along the surface EFGD f bar dot n bar ds is equal to double integral. So here f bar dot n cap, now what is the formula? F bar dot n bar into, so this is defined in yz plane, xy plane. Am I right? This is xy plane. This is xy plane. So this is the equation z is, what is the equation of this plane? Z is equal to a, and here it is parallel to xy plane. Here x varies from 0 to a and y also varies from 0 to a. So here x varies from 0. So the projection of this plane is on xy plane. Am I right? The projection of this plane is xy plane. Here x varies from 0 to a and y also varies from 0 to a. The projection of this one is on xy plane. So x limits 0 to a and y limits also 0 to a. So therefore the projection will be dx into dy by magnitude of n cap dot k bar. Magnitude of n cap dot k bar. So this is equal to double integral f bar dot n cap, that is equal to yz, and this is a dx into dy by n cap dot k bar, that is also 1, n cap already k bar, n cap dot k bar, that is equal to 1. So this is equal to integral, double integral yz dz dy over the surface R1 or over the surface E of GD or over the surface the projection R1 in the xy plane. So this is double integral. So what is the limit for here? Z is equal to a. Here this is z is equal to a. So a y dx into dy, where y varies from 0 to, or x varies from 0 to a, y also 0 to a. All are constant limits. You can do integration first with respect to x or first with respect to y. Both are nothing to worry about, so both are same. So 0 to a, and integrating the function with respect to x, you get ay constant, then integral dx, that is x 0 to a of dy. So then integral 0 to a. So what is the limit? Upper limit x plus a. I am writing x instead of x, I am writing a. So a minus 0, that means what? A square y dy. Am I right? Ya into, this is integral dx xi in the upper limit a square y, lower limit 0. So what is the integration? A square into y square by 2. Y integration with respect to dy. So the limits are 0 to a, that is equal to a power 4 by 2. That is one value. So clearly here, so you can show that this is one value, a power 4 by 2. That is the answer. A power 4 by 2, that is one of the surface integral value along the surface E of GD. I hope this is clear. The first one is a power 4 by 2. This is equation number 1. The surface integral along the surface E of GD. Similarly, I want to evaluate the surface integral along OACB. So now I will go to the next slide. Now the surface OAC, I will show it, OACB. This is OACB. So what is OACB? So here I will write OACB. So for the second surface, this is case 2. So case 1 is a power 4 by 2 is the surface integral. Now I would like to evaluate the surface integral across the surface OACB. So what is the outward normal vector? The outward normal vector for this surface is in the direction of negative z-axis. So on extending this, you will get the negative y-axis, negative x-axis minus x, and negative z-axis. The outward normal vector of this plane will be in the direction of negative z. That means what? The n cap or outward normal vector is equal to, the outward normal vector n cap is equal to minus k bar. Am I right? So minus k bar. The outward normal vector n bar is equal to minus k bar, and f bar dot n bar. F bar dot n bar, what you will get? So f bar is as right in the previous case 4xz I bar, 4xz I bar minus y square j bar plus yz k bar, dot product with n bar means minus k bar, yz k bar minus k bar. So what will be the value? This is equal to only, this is 0, this is 0, only k bar will get, this is minus yz. This is f bar dot n bar, that is the part of the integration. And also here n bar dot k bar. N bar dot k bar is minus k bar dot product with k bar, that is equal to minus k. Because k bar dot k bar is equal to 1, minus sign is already there, it is minus 1. Now we have to evaluate integral along the surface OACB f bar dot n bar into, so this the projection is in xy plane, dx into dy by magnitude of n cap dot k bar. That is the case 2 evaluation of integral, surface integral along the surface OACB. So this is double integral minus yz dx into dy by, so n cap dot, this is minus 1. So what is the equation of this one? This is the equation of OABC is z is equal to 0. You can observe that this is z is equal to 0 plane. So on substituting z is equal to 0 here, put z is equal to 0, you will get the entire integral is 0, that is 0. This is case 2. So the second surface integral is 0. Similarly, I go for the case 3. So what is case 3? I can go for, this is CGDB. Now the outward normal vector is in the direction of positive x-axis. This is y. Positive x-axis, this is equal to I bar. Am I right? So for the surface ACGD, for the surface ACGD, I will write for the surface ACGD, third one. So the outward normal vector n bar is equal to I bar, because the outward normal vector is in the direction of positive x-axis. It is I bar. Then what is f bar dot n bar? F bar dot n bar is equal to this dot product with I bar. That is 4xz I bar minus y square j bar plus yz k bar, the dot product with I bar, because the outward normal vector is in the direction of positive x-axis. So what is, erase it and I'll write, this is I bar. So this is on making dot product, you will get only 4xz. 4xz I bar dot I bar is 1. So this is 0, this is 0, only you will get 4xz. So here what is the equation of AGCD? The equation of the surface. What is the surface equation? Y is equal to A. The surface equation. This is y is equal to 0. Sorry, this is x is equal to 0. This is x is equal to E. The surface is not y is equal to A. This is, I'll show that this is x is equal to A. The surface parallel to YZ plane. X is equal to A. So on substituting this, therefore the double integral f bar dot n bar into ds along the surface S is equal to double integral over the surface. So what are the surfaces? It is ACGD of f bar dot n bar. What is f bar dot n bar? 4xz into, so this is on YZ plane. So dy into dz by magnitude of n bar dot I bar. That is the extension of this integral dy dz, because we are considering the parallel plane to the YZ plane. So the projection will be on YZ plane. So it is dy into dz by n bar dot I bar. So what is n bar dot I bar? Clearly 1. N bar is I bar. So n bar dot I bar also 1. And here x is equal to A. So substituting all the values, 4 A z dy dz, the denominator also 1. And here limits y 0 to A, z also 0 to A. There are two limits. So y 0 to A and z also 0 to A. Because all are constant limits, you can perform the integration according to your convenient, no problem. So z 0 to A, I'm integrating with respect to y first. 4az y between 0 and A, and after that I want to integrate with respect to dz. So this is integral 0 to A. So what is the value? Replace z by A. So 4a square y and lower limit 0 of dz. Am I right? With respect to y, so 4a square z. You have to replace y for A. So 4a square z. So 4a square constant. Integral z dz means z square by 2, 0 to A. That is 4a square into a square by 2. So that is equal to 2a power 4. That is another integral value. So I will show this is 2a power 4. One of the answer is 2a power 4 also there. Case 1 answer a power 4 by 2. And one is answer 0. And one is answer a power 4 by 2 is one answer. And other answer is 0 also there. And the third answer is 2a power 4. I hope that this is clear how to take the outward normal vector to the surface. Then Then we have to go to the surface. What is the next surface? So I will write here. The first value is a power 4 by 2. The second surface is 0. And third surface is 2a power 4. I will keep in mind and I will erase it. So far we have considered z is equal to 0 plane, z is equal to a plane and y is equal to a plane also. Now I would like to consider, this is z is equal to 0, z is equal to a already over and x is equal to a already considered. Now I would like to consider yz plane. Yz plane means z is equal to, yz plane means x is equal to 0. Now I consider yz plane. The third one is the equation of yz plane, fourth one. The equation of yz plane. What is the yz plane equation? X is equal to 0. The equation of yz plane is x is equal to 0. And the outward normal vector, this is the surface, I am considering the surface EDBF. EDBF, that is case number 4. So what is case 4? So EDBF, this is the surface next to consider this is E, not D, O, EOBF. So that I will write here, EOBF. Here, the outward normal vector n bar is equal to minus I bar, because the outward normal vector is in the direction of negative x-axis, so it is minus I bar, and f bar dot n bar. And what is f bar dot n bar? It is the given function 4xz into I bar with minus I bar, that is minus 4xz. So that is f bar dot n bar, and the equation of this plane is x is equal to 0. The equation of this plane is x is equal to 0. Now, the double integral f bar dot n bar ds is equal to double integral on substituting minus 4zx into, so this value replace ds means it is a dx into dy by magnitude of n bar dot I bar. This is the value. But here we have to substitute x is equal to 0. So the entire integral will be 0. This is equation number 4. So we reached 4 equations for case 1, case 2, case 3 and case 4. Now I am going to see that case 5. What is case 5? The equation of this plane. So this is already z is equal to a, z is equal to 0 over, and x is equal to a, x is equal to 0 also over. Now I want to show that the this surface F, this is F, what is this? C, CG, CGFB. I am considering CGFB. Considering CGFB. The outward normal vector n bar is equal to, what is outward normal vector? For this surface, it is in the positive y-axis. So y is equal to a. The outward normal vector y bar is equal to j bar. This is y n bar is equal to j bar, outward normal vector j bar. And the equation of the plane. What is the equation of the plane? Y is equal to a. The equation of the plane y is equal to a. So therefore, what is integral f bar dot n cap? What you will get f bar? This is dot j bar. That means you only will get minus y square. So minus y square into dy into dz by magnitude of n cap and j bar dot I bar. J bar dot I, not I bar. J bar dot j bar, that is equal to 1. So minus y square into dy into dz. But y is equal to a here. So minus a square, you will get integral dy into dz, and limits are y0 to a and z also 0 to a. So I am substituting the limit minus a square into integral dy first, y between 0 and a, upper limit a minus 0, in the first value a. Second value also a constant minus a power 4. So this is minus a power 4. So second integral also integral 0 to a dz, z between 0 and a. So the z, that is a, already one a square is there, negative sign is there, by a power 4. This is the case number minus a power 4. So this I can show that minus a power 4. So this is another integral, minus a power 4. So 2 or zeros already we reached. And the last one. What is the last one? We have to consider the plane. This is the backside plane. So what is the equation of this plane? Y in xz, this is y is equal to 0. The equation of this plane is z, y is equal to 0. So the plane equation y0 means what you will get in the f bar dot n cap. The outward normal vector is in the negative y axis. So n cap is equal to k bar. Here I can write for the surface. For the last surface I am writing. For the surface O OE D F. OEDF. This is the surface. OEDF. So the outward normal vector for the surface OEDF, the outward normal vector. What is the outward normal vector? I'll show it here. For the surface OEDF, the outward normal vector is n bar is equal to minus j bar. But equation of the plane is xz plane means y0. Y0 means the entire term 0. That is case number 6. Last case. There are 6 cases. One is a power 4 by 2. And second one is 0 to a power 4. And other one is 0 and minus a power 4 plus 0. So that means what? What is the value? A power 4 by 2 plus a power 4. I'm adding all the values of the surface integrals. So a power 4 by 2 is one integral value, 0 is other value, 2a power 4 is other value, 0 is the one value and minus a power 4 plus 0. So this is a power 4 by 2 plus 2a power 4 minus a power 4 or a power 4 plus 2a power 4 by 2. So 3a power 4 by 2. This is the surface integral over the surface. Yes, so it is a little bit, you have to consider all the cases. That is only the laborious work is there. But the problem is understanding is very simple. No need of getting any difficulty in this. Just you have to consider the cube and you have to identify the outward normal vector to the surface. In each case, you need to calculate n bar. So similar problem we will do in the same session. So therefore you can get easily how to evaluate the double integral using this square or parallelepiped. So now I will solve the similar problem. So I will get clearance with this because this is also like the same type of boundaries, but it is the rectangular parallelepiped. You have to find the surface integral here also, but you have to consider this that just you can understand easily after solving the previous problem. So yz means this is x is equal to 0. Yz means x is equal to 0. xy means this is z is equal to 0 plane. And xz plane means y is equal to 0. These are the 3 planes already. So based on considering the x-axis, y-axis, z-axis, so the planes are, if x is equal to 0, that equation in 2-dimensional, suppose if it is xy, if y-axis, what is the equation of y-axis? X is equal to 0. What is the equation of x-axis? Y is equal to 0. In the same way, the plane equation, xy plane equation, z0, the xz plane, y0, zy plane, x0. So those are the planes equation. Now, to find the surface integral over the parallelepiped, the boundary is given x0, x2. x0 means yz plane, x0. So and draw the not like this. So this is not the cube, something it is lengthy. So this is the rectangular box. We call it as rectangular parallelepiped. This is x0 plane. Z0 because it is xy plane, z is equal to 0. because it is xz plane, y is equal to 0. This is x is equal to 0 plane. Now, to find the integral, surface integral, we need f bar, the outward normal vector, and the projection. We need all the thing. Already given f bar is equal to 2xy I bar plus z square into y k bar j bar, sorry, plus xz into k bar. This is the given f bar. Now, I am considering this is O and this is A and this is B, this is C and this is O, A, B, C, D, E, F, G. D, E, F, G. So I am naming the vertices. Here, the double integral f bar dot n bar ds over the surface S is equal to integral along OA, BC. OA, BC. That is one integral plus integral along GBEF or FEDZ. FEDZ plus integral along OCGF. OCGF plus along this surface. This is DEAB or ABDE. ABDE. This is another surface integral. Then fifth one. So this is, consider this one. GCBD. 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 And what is the last one? And the parallel of this one is OAEF. OAEF. So these are the different values you need to consider to find the full surface integral of the given parallel pipe with respect to f bar. So I am considering case 1. Already we have done many examples. I will show directly what is case 1. Suppose if you consider OABC, this is OABC. So the outward normal vector is in the direction of the z, positive z minus z. The outward normal vector is in the direction of z, negative z bar. So z is z bar, k bar, sorry. What is outward normal vector? N bar. N bar is equal to minus k bar because the outward normal vector is in the direction of negative z axis. So the n bar is equal to minus k bar. Then f bar dot n bar. F bar dot n bar. This is 0. This is 0. So you will get minus xz only. F bar dot n bar is minus xz. Now, what is f bar dot n bar over and n bar dot k bar? N bar dot k bar is equal to minus 1. N bar dot k bar. N bar is the outward normal vector, that is minus k bar. N bar dot k bar is equal to minus 1. Therefore, what is the value integral? OABC f bar dot n cap into ds is equal to double integral f bar dot n cap minus xz of ds. So this is OABC. The projection is on xy plane. The projection is on xy plane. And the equation of xy plane is z is equal to 0. The equation of zy plane or yz plane, xy plane, z is equal to 0 is equation. On substituting z0, the entire integral is 0. That is the first value. First value, case 1 is 0. Similarly, we go for case 2. What is case 2? Here only I can calculate case 2. So what is case 2? That is FEDZ. FEDZ. The outward normal vector is in the direction of z bar. So n bar is equal to k bar. The outward normal vector is in the direction of z axis. So n bar is equal to k bar and f bar dot n bar. What is f bar dot n bar? This dot n bar. So you'll get value xz only. Am I right? This dot product with k bar. So k bar dot k bar 1 remaining all zeros. So k bar dot k bar is equal to xz. Now here, what is the equation of this one? Y is equal to, this is xy plane. So z is equal to what is given? Z is equal to, what is this equation? Z is equal to 3. This equation given as z is equal to 3. This is z is equal to 3. So therefore, double integral f bar dot n bar ds. Dx means it is a dx dy. So dx dy by magnitude of n cap dot k bar. So this is double integral. F bar dot n cap is xz. F bar dot n bar is xz. But z is equal to 3. So this will be 3x. 3x into dx into dy. And n bar dot k bar. N bar dot k bar also 1. K bar dot k bar 1. F bar dot n bar is equal to xz. So z is equal to 3. So 3x dx dy. And here the limits are x limits and y limits because it is the projection on xy plane or parallel to xy plane. Because what is the projection? The second projection is GF. First projection is OABC. Second projection GF ED. G of D. GF ED. GF ED. So here z is equal to 3. So the value is equal to 3x dx dy. And x varies from 0 to 2. Already given x0 to 2. This is x0 to 2. And y is equal to 0 to 1. So what is the integration x0 to 2, y0 to 1? So integrating you will get 0 to 1, 3x square by 2 between 0 and 2 dy. So 2 square 4. 4 means 6. Integral 0 to 1 dy. That is 6 into y between 0 and 1. That is equal to 6. It is one of the surface integral value. Similarly, we find the other 4 surfaces also. In this way, what is the other surface to calculate? You can calculate EDBE or AEDB. ABD. What is the outward normal vector for this? The outward normal vector is in the direction of x, that is I bar. For the surface, what is the first one? First one value 0. This is the first one value. And this is the second equation. And third equation for the surface DBE or ABDE, right? Case 3 for the surface ABDE. So what is the equation of ABDE? And YZ, x is equal to, what is the value? So x is equal to 2. This equation is x is equal to 2 is given. So x is equal to 2 on substituting. X is equal to, and what is the equation of this plane x is equal to 2? And here the outward normal vector n bar is equal in the direction of x-axis, that is I bar. So integral f bar dot n bar into ds is equal to double integral f bar dot n bar. What is f bar? F bar is a given function 2xy I bar plus yz square j bar plus xz k bar dot product with I bar. So you will get 2xy only. In the second case, it is 2xy into 2xy into. So the plane is, in this plane it is dy dz. dy into dz by magnitude of n bar dot I bar. That is 2 into x. That is 2 2s are 4y dy into dz. And in the denominator n bar dot I bar, that is also 1. And here the limits are yz limits. What is y limit? y0 to 1, z0 to 3. So I'm substituting the limits y0 to 1, z is equal to 0 to 3. So 0 to 3, the integration 4y square by 2 between 0 and 1 of dz. So 4y integration 4y square by 2 and 0 to 1 dz. That is integral 0 to 3. The value 2 2s are 4, 2 into 1 minus 2 into 0, that is 0 of dz. So that is 2 into integral dz is z between 0 and 3. That is 2 into 3, this is also 6. So case 3 value also 6. Case 3 means this is. Similarly, case 4. Case 4 is this is OCGF. The equation of OCGF is x is equal to 0. So on putting x 0, you get entire term 0. In the previous case, we put x is equal to 2. So case 4, similar evaluation. So x is equal to 0 equation and n bar is equal to minus I bar. So I will explain here. For this surface OCGF, the outward normal vector is in the direction of negative x-axis. So the n cap is equal to minus I bar. So f bar dot I bar is equal to minus 2xy. F bar dot n bar is equal to minus 2xy. N bar is equal to minus I bar. So the integral f bar dot n bar ds is equal to double integral. So what is the function here? You'll get minus 2xy into dy into dz by magnitude of n bar dot I bar. But what is the value here? Substitute x is equal to 0. So double integral 0. So the integral value is equal to 0. That is case 4. So one is a 6, another one is 0. One is 6, other one is 0, and 6 is other one, and 0 is other one. We got already 4 values. So now we need to show that the similar values as you can find the similar values and you can add all the values. The values, on adding all the values, you will get the required solution. So what is the last one here? We consider this display OFEA. Considering OFEA, the equation of that one is XZ. XZ means Y0. Y0 means what? The outward normal vector n bar is equal to minus j bar, because the outward normal vector is in the direction of z axis. The outward normal vector is for this surface, the outward normal vector is that side, and that is in the negative side. So n bar is equal to minus j bar. So f bar dot n bar is minus yz square. F bar dot n bar is equal to, I will show it is for the surface. What is the surface? Case 5. For the surface, this is OFEA. The outward normal vector n bar is equal to minus j bar, and f bar dot n bar is equal to, what is f bar dot n bar? That is minus yz square, and double integral minus yz square, and what is the dx dz by magnitude of n cap dot k bar or n bar dot k bar, n bar dot j bar, because y is not there. Dx dz means it is I bar, j bar, k bar terms, j bar is not here, then this is over the surface. So what is the value here? What is the equation of the surface? That surface is y is equal to 0. So I'll put here the equation is y is equal to 0. So the entire integral is also 0. Similarly, we find the last one. So on finding the last one, what is the last surface? So I will show here only. So what is the case 6? Last one. Case 6. What is the last surface? This is the last surface. OABC. This is OABC, the surface. Already OABC is over, I think. This is GDBF, BDC. The last surface is GCBD. GCBD means this is the plane. GCBD. This is the plane. The outward normal vector is in the direction of positive x-axis. So n bar is equal to j bar. And f bar dot n bar, that is equal to yz square. Here the equation of this plane is, so this is an xz plane, y is equal to e. Here the y is equal to e means here y is equal to 1. Y is equal to 0 is backside plane. This is y is equal to 1. Y is equal to 1 means double integral yz square into dx, this plane. This plane means it is parallel to xz plane. So dx into dz by magnitude of n bar dot j bar, that is 1. So here what is x limit? Here x is 0 to 2 and y is equal to, y not y, z 0 to 3. Z 0 to Z0 to 3, and on putting y is equal to 1, it is integral 0 to 2. This is x value, and y value, z value, sorry, z is equal to 0 to 3, and on putting y is equal to 1, it is a z square into dx into dz. So on integrating first 0 to 3, it is z square x between 0 and 2 dz. So I'm doing integration. So what is the value? I'm doing integration, z value 0 to 3 limits, and here I'm putting x to z square dz. So that is 2 into z cube by 3 is the integration between the limits 0 and 3. So I'm substituting it is a 3 cube, 27 by 3. 27 by 3 means 22 into 27 by 3, and 3 9s are 9 2s are 18. So the third last integral is 18. So now when adding all these values, one is 6, another one is 0, some 6, 0, 0. And what is the last one? This is equal to 18. So the sum of all the values is 6 plus 6 is 12. 12 plus 18 is equal to 30, which is the required solution. So in this way, you can evaluate integral f bar dot n cap into ds by using the parallelepiped. Here there are 6 faces, and you need to find for the 6 faces the outward normal vectors according to the surface. So we'll do the last problem also. Evaluate integral f bar dot ds bar. ds bar means the vector area. F bar dot ds bar can be written as f bar dot n bar into ds. ds bar is nothing but vectorial area, which can be represented as n bar, outward normal vector, into ds. Here f bar is given, and here the surface is the cylinder. Cylinder x square plus y square is equal to 9 and z is equal to 0 to 2. Here this is x, y, z. Z0 to Z02. This is Z is equal to 0. This is Z is equal to 0 plane. And Z is equal to 2 means it is somewhere here. Z is equal to 2 plane. So I'm writing parallel. This is the cylinder. Z is equal to 0 to Z is equal to 2. But you have to remember that only in the first quadrant, first octant. So first octant means it is the 8th part. It will not get to the total value. So you need to write only this part only. This is the cylinder lies in the first octant. So this is x-axis, y-axis, z-axis, and these are the parallel. This is the rectangles, because we are considering only the octant of the cylinder. Octant of the cylinder. The cylinder equation is x square plus y square is equal to 9. So we have to find the unit outward normal vector, or n cap. So what is n cap? N cap means it is grad phi by magnitude of grad phi. So there are surfaces, parallel planes means it is parallel to z-axis or parallel to y-axis in the previous problem. But here it is a curved surface. It is a circular surface. So we need to find grad phi by magnitude of grad phi. Given phi is, what is phi? X square plus y square minus 9. The phi is the surface, it is the part of the cylinder. Then grad phi is equal to I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of the function x square plus y square minus 9. So this is I bar into 2x plus j bar into 2y. This is 2x I bar plus 2y j bar. Then the unit outward normal vector n bar is equal to grad phi by magnitude of grad phi. The outward normal vector, that is 2 into x into I bar plus 2y j bar by square root of 2x whole square plus 2y whole square, because it is the magnitude of grad phi. That is, I'm taking out 2xi bar plus yj bar by 2 square 4. 2 square 4 I'm taking outside, it is 2. So 2 will get cancelled, under square root x square plus y square. 2 to cancel. So that is xi bar in the numerator plus yj bar by, so root of x square plus y square, that is root 9. Root 9 means 3. So this is n bar. N bar is xi bar plus yj bar by 3. That is the unit outward normal vector. And f bar is given vector yz I bar plus 2y square j bar plus xz square k bar. So we know that n bar and f bar. Then what is the double integral? F bar dot n bar we can calculate. F bar dot n bar. F bar dot n bar is on making dot product. So first term x, y, z by 3. Am I right? On making these two dot product. Dot product means I bar dot I bar 1, j bar dot j bar 1, remaining all zeros. K bar dot k bar also 1. Here there is no k bar term. So x by 3 dot into I bar, yz into I bar dot I bar 1. So x, y, z by 3 plus j bar dot j bar 1. So you will get 2y cube by 3. This is f bar dot n cap. So this is the function to be integrated with respect to, suppose if you consider the projection in xy plane, if you consider the projection of this In XY plane, this is let R1 with the projection of the cylinder in XY plane. Then it is XY plane means it is the part of the cylinder. X square plus y square is equal to 9. So I'm considering the strip inside the region y0 to x-axis y0 to root of 9 minus x square. Those are the limits for integration. Y0 to 9 minus x square, and x varies from 0 to 3. So the complete integral, double integral 0 to 3 one limit, and 0 to root of 9 minus x square, the function value xyz by 3 plus z2y cube by 3, the function is dx into dy. This is y limit x. So on integrating, you will get the total value, and this will as exercise for the students. And with these few problems, I conclude my lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.